So the lab we have is we're talking about this week, acceleration of free falling object. So what we want to do is we want to measure the acceleration, and we said in our class it is 9.8 meter per second squared, but is this really the case, right? So this lab provides us a simple way to measure the acceleration. So, well, when we're doing in our lab room, we use a totally different approach. That approach is more accurate, but since you guys are at home, so I decided to, based on the equipment and everything you use, I decided to make it easier, simpler. So the formula we're going to use this one, okay? As you guys already seen, this is one of our 4 formulas for constant acceleration motion, okay? Now, what we want to do is you want to drop something off, okay? Hold on. For example, a ball, okay? It could be a ball or any object you choose, okay? You could drop it from any height to like your table, okay? So anything that could work, okay? Anything you feel like convenient. As far as this thing's not like easy to be broken or something. Okay? Now we drop it from the rest. So the initial velocity is gonna be 0. So there's no this term here. There's only the second term, 1/2 a delta t squared, okay? And from there, you can solve for a. You multiply 2 and divide by delta t squared. So you have 2 delta x divided by delta t squared. So in order to measure acceleration, what you need are very simple, a distance and a time, okay? So let me, hold on 1 second. Let me change my background, okay? I'm gonna change it to be no background so it's easier to discuss this. As you can tell, I'm in my office right now. So how about distance, okay? Say the distance basically is how much this thing traveled, right? And you can use something like a meter stick or tape measure to measure it, just like you measured lengths in the previous lab, okay? So for example, this one here, right? Hold it to it tight and make sure it's the same height, and then measure this height from here all the way to the top of where you want to drop it. You can drop it to the floor, it doesn't matter. But the important thing is when you measure distance, right? See, because when it hits here, right, you want to measure the height of the table. So when it's here, you need to measure it from the bottom of the object, right? Because it's the bottom of the object that hits the table. So the actual distance you need to measure is all the way from this here, the bottom, to the tabletop, okay? In my case, okay? That makes sense? Okay, now another thing, you need to measure the time. Say suppose you know the distance already, okay? Well, if you think that you may change your height, like by holding it, you could use something to kind of label it, like to a certain height. For example, you could drop, let's see. You could take a box and then just drop it, like you make sure you drop it from the end here, the edge here is going from right here. So you measure this distance, right? So then you can hold the ball like this, you know, I mean, this way it doesn't change, you know. And then when you really start to run it, right, you need to measure the time it takes for this ball to go from here all the way to here, okay? Now, how do you do that, okay? That part actually is critical because if you, I mean, the simplest thing to do is take a stopwatch. Even if you don't have a stopwatch, you have a smartphone, right? It has a stopwatch on the phone, right? One of the app, you could use that, but that might not be very accurate, okay? It really depends on how good you are. For example, when you you should start to count the time right after you drop it, right? Or the same time you drop it. And then you should stop counting right at the moment it hit the ground, okay? Well, this part here to start is not hard, but when to stop, it might be hard. You know, you want to make sure that you measure as accurate as possible. So if you try the stopwatch approach, see whether it works, okay? If it does not work, try something else, okay? One idea would be, for example, you know, you can video yourself dropping this, like you can video it, dropping the whole process, you know. When you video it, you have all the times recorded, and then you can go back to your video and see how much time it actually take for the ball to start from here all the way down here. One problem is that approach is I tried it on my iPhone, the problem is on the iPhone by default, the video you have there only shows you a second, like it go like 1 second and then 2 seconds and 3 seconds. Although something happened in the middle, it does not show anywhere in the middle. Okay, so in order to use that video, you may want to find some other app that can give you a better accurate time measurement than just a whole second. If it can go to like a 1/10 of a second, okay, that'll be great. Okay, if it does not only give you second, but also 1/10, like for example, 1.5 second or something, you know, or 1.6, that'll be good. I mean, because that's way more accurate than just saying it's 1 second or 2 seconds. So for that approach to be applied, you need to actually have a better app to look at your video so that you can go very accurate time. Okay, did that make sense to you guys? Or you may try this stopwatch. Okay, now there's some app online that allow you to do that, but some of them you may find some app on this. I had an app that can do that, that can trace the time very accurate, but unfortunately that app right now costs money. It's called Video Physics, but it costs money, so I don't want you guys spend money for this unless you have a lot of money to spend. Okay, so try to find some free apps, you know, that can give you that kind of a thing. I think you guys are smart, you know technology better than me, right? You grew up with it and you kind of you live with it, so you're way more comfortable about this stuff. So try to maybe on Monday, okay, try something on Monday. Let me know what's your best way to measure the time. Okay, again, that's a critical thing, because you don't measure it accurate, you'll get a big error in your acceleration calculation. Okay, so that's basically how it works. Any questions so far? Okay, so and in the end, we want to compare it to the expected value or theoretical value. Okay, we can calculate the percent difference using this formula. Okay, so the procedure is really simple. Just pick up an object to drop, measure the distance of drop, and drop the object, measure the time. Okay, and then repeat this 5 more times. So totally you have 6 trials. Okay, so I put this 6 trial in this table here, so you can use that. Well, the first one is the object, whatever object you use. Write whatever you use. What I require here is you use 3 different objects. For each object, use 2 trials. Okay, and start from different height for this object. Okay, go do it for 3 times. Okay, so you can choose whatever object you want. Just don't choose something with a huge surface area like this, right? This certainly is not gonna be good for our measurement, because air resistance play a huge role. Just choose some object with pretty significant mass and also very small, relatively small surface area. Okay, so do 1 object for 2 trials. So use totally 3 different kind of objects. For each object, use 2 different heights. Okay, so there are going to be different numbers for distance, and then measure the time corresponding and calculate the acceleration using this this formula right here. Okay. Now after you got all of these, right, make sure you got the units here as well for these. Okay, not for the object, but for all the quantities. Okay. Now in the end, take an average of this acceleration of these 6 trials. That'll give you an average number. And as we explained before, an average of multi-trials normally is a little better in terms of accuracy than the individual trials. So take an average, you got it here, and then finally calculate the percent difference using this formula right here. Okay. Again, make sure you show the calculation in your lab report, and also explain the theory. Okay. Now I give you the formulas here, but still I want you guys to provide them on your lab report and then try to explain them a little bit. Okay. So that I can see you understand the physics behind it. Okay. Now this lab, as I said, is not very accurate because for each motion we only measure 1 number. When we did it in our lab, normally we do a curve fitting for the whole motion. But since you guys are at home, so I think that's the best thing to do. Okay. Do you have any questions for this? We're good.
So if there's only the table, is it okay if we just include the table in the lab report and just do it that way, or did you still want us to send in both the data sheet and the lab report with the table?
Again, if you can make an identical table on your lab report, you do not need to send this one. This is just a guideline for the table what kind of table I'm looking at. So I think you can put this table, copy and paste it to your lab report, and then just send the lab report. That's sufficient. Okay. Yeah, so this lab, I think it's kind of fun to do it at home, with this kind of thing. It's not very hard to do, and you only measure 2 quantities and you get the expression, which is very important, as we know, 9.8 is very, very important. So